Now we're going to make our ladybug a little more intelligent. First, we're going to make it look for targets or collisions or things in front of it that are blocking it so that it can turn around. If it hits a wall or hits a block or something, I don't want it to keep going. So to do that, we're going to add some raycasts to our ladybug script. Well, really, we just need to add a single raycast to it that's going in the forward direction. So we'll open up the script. And before we set our rigid body velocity, let's add a few lines. And let's first figure out where we want to shoot a ray from on our character. Let's go take a look at our ladybug right now. So on our ladybug, we want to shoot a ray out right from the eyeballs or right from kind of the front or the edge of this collider is even fine. Like right here, if this thing touches at all, we can probably turn around. We don't need to go all the way up and bump. So I want to figure out what the point is right about here. And to do that, we can use the collider. I'm going to go back into the ladybug script. And we're going to create a vector2 for our origin. We'll say vector2 origin. This is going to be the origin or the starting point of our raycast. And it's going to be equal to our transform position plus, and then we want an offset in our direction, but we want it to be the direction times the collider's bounds extents. But let's actually do that on a new line up above because I think that'll make it even more explicit and more obvious what we're doing. I'm going to call this a vector2 named offset, and we'll assign it to our direction, which is going to be either -1 on the x or +1 on the x. And we're going to multiply that by our bounds of our collider or the extents of our bounds of our collider. So say collider.bounds.extents. And, we want the x. So we want that width off to the x times our direction. So that's going to give us an offset, either positive or negative, equal to the extents. And if you look at extents in the Unity documentation, you'll see that it's always equal to half the size of the bounds. And this is essentially going to give us the distance from the center of our collider to the edge of our collider if we get the extents.x value. That's what it's giving us. So that's why we're able to get that exact left edge. Now that I've got that, we can add that to our transform position to get our origin. And we've now got a point right on the edge, except that it's giving us an error here because it doesn't want to combine a vector2 and a vector3. So just like before, we're going to cast our position as a vector2. Now we've got a origin that should work perfectly fine, and it's offset. So we need to now add our code for the raycast. For our raycast, we have two different options. We can do a raycast that finds one object. Well, there are actually a couple options, but we can do a raycast that returns one object, or we can do a raycast that returns multiple objects. And there are ways to do multiple object ones that are even more efficient, and we'll talk about those in a little while. But what we want to do here is actually scan or search for more than one item. And the reason for that is that when we do the raycast, there's a good chance that we're just going to catch our own ladybug in that raycast. We might, even if we're right on the edge, we still might end up colliding with ourselves. It happens a lot. It's not going to happen consistently. And we could, of course, move this off to the edge. But I think that getting a raycast of everything and then just ignoring ourselves is a slightly easier and cleaner solution. And it shows you how this stuff works without having to get really tweaky with your exact variables and sliding out, what 0.001 further so that you avoid a collider. So what we're going to use is the physics 2D raycast all method. So let's scroll down a little bit and we'll say var hits equals physics 2D dot raycast all. Now we need to give it an origin, which we've already created. An origin. There we go. Oh, look at that. I spelled it right. Then we need to give it a direction, which we already have. And then finally, we need to give it a distance. So let's call this the raycast distance. We need to add that as a variable though. So we'll add a serialized field for it. So generate a field. I'll hit F12 and we'll go up and replace the private with a serialized field attribute. Let's go fix that S and then cut it. So Shift delete and move it right up here to by our speed. I'm going to give this a default value of maybe like 0.2. That's like 2/10 of a meter out, a little bit further than 1/10 of a meter out. And then we've got our hits. Now we should be able to get back a list or a collection, or really it's an array of raycast hit 2D objects. And then we'll loop through all of those and see if any of them are not our own ladybug. So to loop through each of our raycast hits, since it returns back an array, and you can tell it's an array there, by the way, because of the two little braces right after the raycast hit 2D. The square braces say, hey, this is an array, and raycast all needs to return back an array. There are also versions of it where you pass in a parameter and that gets filled. We'll talk about those later. But for now, we're going to loop through each hit. We'll do that with a for each loop. So you just type for each var hit in hits. This is going to loop over or iterate over every single hit in our array and then allow us to run some code on it. So I'm going to hit enter, add some braces, and then figure out what that code is. The code that I want to do here is really to check to see if the thing that it hit was myself. If it wasn't myself, then I want to flip my character around and just switch the direction and maybe flip that sprite. So we'll say if hit.collider is not equal to null and hit.collider is not, or .gameObject, let's get the gameObject, is not equal to our own gameObject. Now we could also theoretically compare the collider. So we could say if hit.collider is not equal to the collider that we've cached here. That would work as well, unless I end up adding multiple colliders to my ladybug, then we'll run into a problem. So I'm going to compare the game objects instead of the colliders, and then we'll just run some code if I've hit something that's not me. And that code is going to flip the direction, and to flip a direction or flip a vector 2, all we have to do is multiply it by -1. So we'll say direction, or underscore direction, star equals, which is going to multiply it by the value after it, and we'll put in a -1. So if it was 1 and 0, it'll become -1, 0. If it was -1 and 0, it'll become +1 and 0. 0 is that y value. The x is what's really flipping here. The next thing that we need to do is flip the sprite renderer. So we'll say underscore sprite renderer. Let's see if I can spell that right. .flip x, and we want to set it to true if our direction is right, because our ladybug is facing to the left by default on that sprite. We want to flip it over if our ladybug's direction is right. So we'll say it's true equal, or if direction is equal to vector2.right. Oh, I got one extra equals there. So we're assigning it and then doing a comparison. I had double equals there. That was the error that just disappeared. So that should do it. Now, if this happens and I find something that's not me, I want to break out of this loop. I don't want to do this multiple times if maybe I find 2 colliders there. So we'll just add a break. What that'll do is if this we'll loop through each hit. Any hit that actually meets the condition that's not us, we'll flip it around, change the sprite, and then break out of the loop so that we don't continue on and try to find another hit. Let's save that and go test it out. We should now be able to watch our ladybug go back and forth as long as it's hitting something. Although right now our ladybug is going to walk off to the edge, so I probably need to add another block over there to the edge to stop him. Let's do that before we hit play. We're loaded in. I'm going to grab one of these bricks, duplicate it, and hold control and just drag it right over. We'll save, press play, and let's see if our ladybug will do its walking back and forth. All right, there it goes, and it's walking around. It's getting pretty close to the edge and stopping when it gets about 0.2 meters out. And I can, of course, turn this down to like a 0.1, let it get a little bit closer. And I can turn this up to something like a 1 and make it turn away much earlier so that it keeps about a meter away from things. So it seems to be working. I'm going to put that back to a 0.1, adjust the speed just to make sure that that's working too. Looks like a value of 2 works fine, or a value of 0.5 might work as well. Have a nice slow moving snail. But now that I've got my snail moving and turning around on walls, I want to commit it before I worry about making it turn around on cliffs. So let's go into plastic, make sure that we're saved up, and say that ladybug turns around when hitting a wall. And if you're running into an issue with it, you're having a problem with it, in the next section, we're going to add gizmos to help debug that a little bit more and make it a little bit more explicit and obvious where our array is happening. So just continue on to there and see it and hopefully solve any issues that you have. Hopefully there are no issues though. It should just work. So let's check that in.